Hello, welcome to this tutorial video in JavaScript using the P5 library, where I'm going to show you how to make a 3D environment that you can navigate around. So this is a very standard thing if you're working in something like Unity or other game development environments, but not so much for JavaScript, and certainly not for simple JavaScript things. So I'm going to show you how to do this. Hopefully. Why am I even saying this? It always goes wrong. I always take longer when I say time. Right, we're going to try to do this in half an hour. Let's do it. Right, so it's 10 to 7 now. So using maths is going to be like, something like 20 past 7. I've got till. Okay, so there we go. So this kind of thing we're going to make. And this was a thing that I couldn't work out how to do, although for the longest time, and I couldn't work out the answer. And so you might be in a similar position where you've got actually all the tools that you need, namely polar coordinates, which I'll go through. You can make 3D objects appear where you want them to appear in a scene, which is very simple to do using P5 and WEBGL. But then putting those two things together, logically, you should be able to, maneuver around and look around, and then you'll notice things going wrong, like you won't be centered in the middle of the world, so when you rotate it around, it won't create the illusion of a first-person perspective, and so forth. And I found basically the reason is, and so if you're not enjoying this video, you won't have to watch the rest of it. The answer is P5 places you not at 0, 0, 0 for your X, Y, and Z position, but at, so I'm just stretching, but at 0, 0, 700. Is that right? 0, 0, 700. So 700 plus 700 on the z-axis. So, in other words, all you have to do, if you already know what I'm talking about in terms of having your player position, your first-person position controlled or kept track of via polar coordinates for where you are on the x and the z axis. So if you've worked out that yourself, all you have to do is translate to that position, not 0, 0, 0, but 0, 0, 700, then do your main rotation, your player rotation, and then everything else will take care of itself. Okay? So now you don't have to watch the rest of the video, if that made sense. So for the rest of us, let's try and make something like I've done now. And by the way, what I've got on here as well, I'm just zooming in via the Mac. This isn't part of the my program, so the resolution is not very good, but also I quite like this, rotating planets, and I've got a high resolution texture as well. So hopefully, if we have time, if we get the main mechanic going, we'll go and find some textures, and I'll show you how to do that. In fact, let's do that first of all. Let me just show you that. So in my folder, I've just gone and grabbed some textures like this, or just JPEGs, 2K JPEGs, and let's see if I can show you where to go. Yeah, if you go to, you can just about see that, can't you? Maybe if I just bring that into shot a bit more. There we go. If you go to pexels.com, this is not a sponsored video or anything. Hello. It's not a sponsored video or anything, but yeah, Pexels, it's royalty free, free to use. I mean, like public domain, so you can put something in like, it's Happy Christmas, by the way. It's December, very close to Christmas, isn't it? 2019, if you're watching from the future. Snowflakes, or the past. I don't know how you've done that. Well done. Hello to you as well. We couldn't find anything on snowforks. Okay, I'll use the standard definition of spelling snowflakes. Snowflakes. And there we go, you got loads of snowflakes, and then you can either download that to your folder, or if you're working on CodePen or something, what you do is bring up the picture like I've just done. So just by selecting it, click on it, and then if you right click now and go to copy link, you can then load that texture into your, let's go back to our editor, you can then load that image via a URL like this. There we go. and then you can, that means on CodePen you can just load it from this site. In fact, I think we just have to, oh wow, you can actually click on it. I think you can take away that as well. Interesting. Oh, it is working. Oh, that's really good. I mean, I'm using brackets, by the way, for the code editor. So I'm just highlighting this URL, and it's gone, linked itself to the URL and given you a preview. That's amazing. So that's how we can, load images. Load images in. I'm just assuming that you're familiar with P5.js and what load image means and things. Don't worry if you're going from scratch and you don't know what I'm talking about. That's just for some other people. And you can come back to this bit and it'll be useful for you later on. Right, I'm just going to undo that. Right, so I've got it working here, the 3D system working here. So let's make a new file. Where's, oh, new. It's really funny when you record yourself doing anything, the easiest things become really difficult. So I'll save this as tut 3D world.js. There we go. So we've made a new JavaScript file. So if you're working on CodePen, you could do it up there. That would have been a good idea if I did it on CodePen. And then I just need to change what my HTML file is loading. So we want to load tut 3D world. There we go. Save that. And save them all. Okay. If you are working on CodePen, you must link somewhere the P5 library. I've got the minimum file here. It's currently on version 10.2. So to do that, I'm not going to show you on code. You know what? I've got lots of videos that show you how to do this. So you go and have a look at that. But let me just quickly show you where you might find it. Cats don't need juicy sausages. So cdnjs.com. There we go. You can put P5 in there and it will find the sound one. There we go. P5.js library, and it's on 10.2, and you could copy that, copy the URL, or copy the script tag, and then you can just paste that script tag into your HTML file, the HTML file which is hosting your JavaScript, your code, and then you'll have the library attached, and which is exactly what I've done here in my index file, my HTML file. I've got it linked there. So that tag that that tag is this script tag here. Okay, I'm being really incoherent. Sorry. Let's get doing the 3D stuff. Okay, so JavaScript now. So we're going to use the setup function, which is where the program will start, and we want to create a canvas. That'll sit on an HTML page, and let's just do 400 by 400 pixels at the moment, and we'll give it a background color of, should we just have random pinks? Okay, random 255, no green, and then random 255. Okay, save that, and let's just run it, and hopefully we should have some kind of pink square. Yes, lovely. And if we refresh the page, we get, different shades of stuff. So, so this random keyword is a P5 function, so is background, and so is create canvas. None of those will work unless you've attached the P5 library to your project. Right, so we want to go 3D now. So to go into 3D mode, P5 has made this so easy. Capital letters, just write WEBGL as a third component, third argument in our create canvas function. So if we run this again, it should look exactly the same. Yeah, there we go. So the only difference is in 2D graphics, let's just zoom in 2D graphics, the origin of our drawing in terms of the x-axis and the y-axis will be up here, top left. That will be 0 on the x, 0 on the y. 3D graphics, 0, 0, 0, because now we have the z-axis. Minus on the z-axis is going away from the user. So for you guys, it's coming towards me, I guess, if you're thinking in relative to your own screen. It's going this way into the world of the screen, and it's coming out into your reality in terms of being a plus number, not a minus number. So that's the z-axis. So 0, 0, 0 is right at the middle. Right. So things are working okay so far. So what do we need? We need some objects first, and then we'll move around. So let's go and draw some objects. Let's make an object. Let's make a class, and we'll call him box. It's conventional to have a capital letter when you're making a class in JavaScript and other programming languages. Then we need our constructor function, which will be called when we want a new object. And this is where you store the member variables for your object, such as its position, things like that. In fact, we do want a position, so we'll have a position stored as a vector, a position vector. So it's just a variable that can hold 3 numbers instead of 1, 3 values instead of 1. And to make that using P5, we can just say create vector, because vanilla JavaScript doesn't have a vector object, does it? I don't think it does, I don't know. Else why would P5 have a vector object thing? I don't know. So if we just write position equals create vector, that function, P5 function, will go and create a variable with 3 component spaces in it. So we could explicitly put 0, 0, 0, but it will assume 0, 0, 0. In fact, let's say I want x, y, and z, and try z, and we'll take that from the parameters of our constructor. So when you make a new object, you have to specify where you would like your box to be created, something like that. Okay, right. So it's got position, and we don't want it moving around or anything. So we'll just have a function. So this is a member function or a method I guess. It's not going to have a return value. Render, and all we want to do is draw a box in 3D. So you write box, so this is the WEBGL P5 function, box, and then do you just put in, I can't remember now, I think you just put in the radius of the box, something like that. So let's put this rad, I think that's right, this rad equals, and by definition, sorry, by default, let's just have it 20 units, whatever those units are. Okay, so create a box, hopefully, of this many units. So how do we position the box, first of all? So we use translate. So you're going to translate the position of the box, and then draw the box there, and it'll appear there. And we're going to translate to its position X, Y, and Z. Okay, save that. Okay, we won't worry about its color or anything like that. We just want to get the mechanic, don't we, working. So, by the way, I'm just assuming you've nodded or said yes, and carry on. Let's make a box just to test this out. Let's make a lot of boxes because it's just about as easy to do that. Now that we've got an object, we've made our own object, we can make lots of boxes easily, which we want to do, so we can kind of make sure the mechanic's working. So we'll call our array boxes. Again, it's a convention to pluralize the name of arrays, and to declare an array in JavaScript, we'll write boxes equals and then square brackets. And in setup, let's go and get a load of those. So we'll have a for loop. And how many boxes? Let's go for 100, and that'll be easily handled. So we've got for loop, and what we're going to do is push to boxes. That means put on this array, put on a new object, and because we're going to instantiate one of our own user-defined objects, we use the new keyword. That means, JavaScript, could you go and look for an object that's defined by us somewhere else? So this is kind of like the recipe or the blueprint of our object. So we'll go and look for that class. And you know what? Do I write class with a small c? Yes, I do. Yes, I do. And so we want to go and find box. And now we've got to put it somewhere. I think there's a p5 vector random thing. Anyway, I can't work it out right now. Let's just put random out of, well, we want to go from, let's go from minus width. So width will be a keyword. Whatever width you've got here for your canvas size, X and Y, then that will be taken as the width. Did that make sense? Width to positive width. And then we're gonna, this is, I need to format this somehow. Let's make this look nice. Nice in terms of being kind of like understandable for a human. There we go. So that's the Y position, and then Z position will do exactly the same. There we go. So that one goes with that, that goes with that, that parenthesis goes with that one. Okay, so all we've done there is say choose a random position constrained by whatever width we've got here, and then go and create a new box. Each one, so it'll have a random position, 3D space, but it will have hopefully a radius of 20 units. Okay, so now we want to go and draw all of those. So, oh, we could just do it in the same, just for testing here, just to make sure our render function works. We want to say boxes. Which box do we want? We want, well, length minus 1, because we start counting from 0. So let's say we've pushed on our first box. That will be stored at boxes 0. So box's length will be 1 because we've added our first 1, but we don't want the index 1 in the array because we start counting at 0. So this will mean we start counting at box 0. Okay, that's correct. We want to then render you, please. Okay, so that should create a box, then render it to the screen. And let's just see if it runs. Okay, it's beginning to run, and we've got pink. Okay, so at least oh, I was going to say, at least it might have worked. Don't know what the first one. Okay, so sometimes they're all kind of close together. Sometimes not. Okay, so we've got lots of boxes, 3D boxes. They don't look looks really bad. I thought it looked a bit better than this. It might look nice if we can start moving around. So so far so good. Let's make our window a bit bigger. You can put in window width, and I'll just go into a new line, window height, and then dynamically when we call this function, JavaScript will take in whatever window width and height you've got and fit the canvas to that. And then width in turn will refer to whatever window width it took. Lovely. Okay, all the boxes are kind of over here. Very nice. Right. Okay, so it's beginning to work. Let's make the boxes a bit bigger. If I make them 10 times as big, Will that be silly? It might just mean that we can see the boxes a bit more easily. Nope. Okay, yeah, they're a bit more sizable. Okay, so we've got an environment that we can go and explore. So now we want to create a position for our subject, our player, first person perspective, and we want to rotate the world around that player. So let's start with just rotating the world when we press the keys. So what we're going to need, we're going to need a variable, we'll call it theta for what angle we're at. We'll start at -9, no, we'll start at 0. Okay, and we'll label these player rotation. How are we doing for time? Not great, we've got 10 minutes. Right, player rotation. While we're up here making variables, we'll make our position. So we'll say player x equals 0, let py equals 0, let pz equal 0. Right, this is the setup function. We're going to need another function to work as our game loop or our update loop if you're used to using something like Unity. Function draw. So once you've got a function draw, P5 library, after it's run setup function, it will then go and run the draw function over and over and over again. I've just got the urge to make my writing a bit bigger. Is that better? I'm really sorry if the code was a bit too small. I think it was okay. Now it's really big. Right. So I think in 3D we won't have to redraw the background. I don't know. We'll cross that bridge when we get there. But what do we want to do? We want to first translate to our player position. No, we want to translate to the middle of the scene, which will be translate 0, 0, 700. That's the key number. So that will be the center of where the camera is. Then we want to rotate around the y-axis. The y-axis is, imagine it like a pole, like that, and so everything's going to turn around that axis. And that's in radians. And we want to rotate by theta. There we go. So position at center of world, then rotate by player's rotation. Simple enough. Then we want to translate by the player's position. So we want to translate to players X, players Y, and players Z. Lovely. Okay. So now move to player's position. And now we can draw all of our boxes, or render all of our boxes. So hopefully we can just use this for loop. Am I talking a bit quietly there? I just realised, kind of talking to myself. And we won't say up to 100 because we might change that number in setup. So we just want to say how many boxes we've got. So we'll just say the length of the array. And we don't want to make our boxes here. We've already done that in setup. But we do want to redraw them, want to render them. Okay, right. Let's just see if this is working in terms of are introducing any bugs. Looks like we're inside of a room here. Very nice. Very nice. Okay, so we're doing the same sort of thing. We haven't broken anything yet. Right. Let's see if we can move backwards and forwards. No, let's see if we can rotate. That's what we want to do first. So in the draw loop, let's make a function where we can say like check input. So we want that to be looked at every time, or checked every time we're going around the loop, going around the game loop. So we're going to have to write the function here, and I'm going to go and grab the keys from what I prepared earlier. So this is all that will be, yeah, that will be the rotations. So if key is down 37 or key is down 65, so that would be left arrow 37. Let's just write this in. Left arrow and or, which is this logical operator. If you press shift and kind of like forward slash or backslash near the enter key or return key on my keyboard to get to him, do two of those pipes. That means or, the or operator. So left arrow or A. There we go. And similarly, we'll have right arrow or D. That's key 39 and 68. By the way, if you go to, here's another thing. Oh, I'm just giving you loads of things. If you go to JavaScript, what's it called? Key code. Key event key codes. There we go. Keycode.info. Keycode.info. Made by Where's Boz. Brilliant. It will give you the key code number, which is really handy, isn't it? So A is indeed 65, D is 68, W 87, S 83, left arrow is 37, right arrow 39, forward 38, and down 40. There we go. So I've got those there. So what do we want to say? If we've pressed the left arrow or A, we want to rotate left. So theta equals theta, we'll say minus rotation speed. Let's just try 1. There we go. And then presumably if we press the other one, we want to go around the other way. So let's just see if that works. If we've got our rotation, there's nothing there, but now we should be able to look behind us. So I'm holding down the left arrow key and nothing's happening. I'm going right. Maybe there's just not any boxes there. Let's just refresh. Okay, we can see some boxes. Okay, I'm touching the keys and everything, and actually nothing's happening. So I've done something wrong. Well done at home if you've worked out what the bug is. Oh no, there are no like explicit bugs in the console. I pressed Alt, Command and J on my Mac here to bring up the console, by the way, if you didn't know. I'm definitely checking the input, aren't I? I know that this code kind of works in terms of the arrows and everything. I'm drawing the boxes. Oh no, I'm stumped. And we were moving along quite well. What's going on? Check input. Am I definitely in the draw loop? Yes. let's just check that I don't have to do something silly like change the background colour, is it? No, I don't know. I think we'd still see some movement. I don't think we have to save and revert the drawing matrix here, do we? I don't know if I've saved that, sorry. No, that didn't seem to make a difference. Oh, now something's moving. Why isn't everything else moving? Okay, let's just try redrawing the background. So background, say 200, 0, 200, some kind of pink. Okay, this is really odd. So they're being drawn. Okay, let's just take away, maybe there's some push and pop here. Why is this not going right? What am I doing? Radians. Background. I'm translating to there. Let's try running it again here. Okay, that seems more stable. Radio silence from me. What am I doing wrong here? Right, let's go and have a look at my other code. And I can see what this does differently. So setup, ambient material, text size, subject's position, draw. We do refresh it, incidentally. I do my input there, untidily in the draw loop. Yeah, there's no pop or push. So I translate, yep. Then I rotate, almost exactly the same. Translate to the subject's position. And then draw the objects. That's exactly the same, I think. So background, I redraw the background. Translate to 00700. I rotate around Y. Oh, wait a minute. I bet it's my objects doing it. Yeah, these are all translating somewhere. So I have to save the current position of the matrix. Ah, I see what's happening now. Okay, I'm just gonna even if this isn't the right answer, let's risk it. So I'll explain now before testing to see if it works. So what push does is save the current state of translations and rotations. So it saves, imagine like a matrix there. Saves that. And then you can go and do some other translations, like here, which again translates the center of where we're drawing from to somewhere else. And then you do your drawing, and then if you think about it, if you then go to draw another box or another 100 boxes, each of those translations accumulate, build on top of each other, so you're drawing further and further away from where you're supposed to be drawing. So each time you draw an object within the scene, you want to save the basic origins or rotations of where we're looking, draw it, and then revert back to the proper orientation to draw the next object, which will translate it a bit and rotate it a bit, and then revert back before drawing the next object, and so on. And to do that's quite easy. You just call push before you do your translations or rotations, and then pop to revert to the saved state. So it's almost like you're saying save and then load to the previous state. So save that, still with the confidence ringing in my voice. We start it up, and they all disappear. That didn't look good. Okay, there's one there. Okay, it is rotating around us. She'll be coming around. There she is. So the question is, where did all the other ones go? Where did they all go? So what's going on? It's, to be honest, it's just like we are accumulating one on top of the other. I don't think it makes a difference if we do our input checks up at the top. Well, it might be because I go and do a load of things here, because I draw them at the start, which I don't do in my other program. Again, there's only one box appearing. Okay, let's go and think this through. Sorry, before I give you epilepsy. Sorry about that. Setup, create canvas, background, yeah. Boxes, push a new box onto the array, check the input. So I translate, then I rotate, then we translate the position, then we draw all the boxes. So that was exactly what I was doing here. So we refresh the background. I'm just doing it by my own function. Yeah, we translate, rotate. Let's just double check I've done that. Translate, rotate. Yeah, that's exactly the same. And I translate to the subject's position. Zero, zero, zero. Mine 0, 0, 0, 0 as well. And then draw the planets. I'm using for each instead of a for loop. So let's just go and inspect the render function of my object. So here's my planet. So I've got position, position X, Y, and Z. It's got its own rotation. Yeah, push and then pop. Bizarre. Create vector, X, Y, Z. Push and then pop. Position X, Y, and Z. we could just try making it a sphere. I really am at a loss as to what's going wrong. It looks exactly the same. At least I've shown you the code. So the many planets code is working. 24, by the way, so it's radius of the sphere there. 24 is kind of its detail, so I'll just leave it without that detail, so it's a default. So I'm just wondering, is it something to do with how I'm drawing the boxes? So I've got a sphere down here. What looks to be happening is it's drawing all of the boxes in the same position. Or spheres in the same position. So it's not an issue with them there being boxes. Let's write box again. It's something to do with this for loop. Length. Oh! Is it because we're going backwards through the... Oh, it is, isn't it? No, we're going forwards. We're going forwards through the loop. That's right. 0, 1. Oh, so we can just say... Ah, yes. Ah, I am so sorry if you saw that bug. That must have been the worst thing to watch. But there we go. So, and I wasted so much time on that. That might be what you've come for. A bit of debugging. There we go. So that's what I should have had approximately 15 minutes ago. So we can look around. Okay, the last two things I'm going to have to, because of time, paste in and just talk you through. Okay, so how do we move forwards and backwards? So basically, we just want to change our x value, so this way in 3D space, and then our z position, our z value. And if you think about it, like if you're looking down on yourself, imagine bird's eye view. Really, all we're doing is polar coordinates, i.e., depending on our... Imagine that we tipped up the world, sorry, so you're kind of looking down the y-axis now. So we've got z this way now, and x this way. So really, if you imagine a circle and our players at the middle of the circle, their rotation has a value, and we've called that theta. We just need to decide, depending on that angle, if you're moving forward, how much are you going along the x and how much z? And that's polar coordinates, i.e. if you have the angle, theta, you can work out using sine how much of x and cosine how much of z, or vice versa. Right, so we're going to go and copy and paste, and I'll just quickly explain them. Have I gone past them? No, they're up here. They're up here. Here they are. Right. We'll just do 38. I think 38 is forwards. We'll just go forwards and you can negate it to go backwards. Look, we've got plus happening here and minus happening here. Everything else is the same. So you can go and reverse that yourselves if we get it working here. So we want to go to our check input and we want to move forwards, please. Happy face. Happy face. Paste that in. So if key is down, 38, I imagine that's a forward key, forward arrow, then we want our player's x to increase itself. So plus equals is the same thing as writing px equals px plus whatever this is. And we want to have sine minus radians r, or r is our rotation. And then how much on the z-axis do we want to move? Or sorry, the z-axis, that would be cosine. Let's run this now. And hopefully we'll go forwards or backwards. Oh, we're going forwards. Can we steer right? Yes. Can we steer left? Brilliant. We can go back on ourselves, and it's all working. So there we go. 3 minutes late, which for me is a success. So we got some debugging in there. I showed you how to do textures and things, to slap on some textures. Go back in the video. You know what? I won't do anything, but I'll just show you. If we go back to many planets, where I was drawing each planet. There we go. Texture. Before you draw your sphere or your box, whatever, if you just write texture, and then in here the variable name of where you've stored your texture. So if you load your textures, you can call it, for example, moon t equals this texture that we've loaded, or whatever else. Okay, and then it will slap P5 WebGL Magic will slap that texture around your sphere, and you can have very good looking stuff. And what I'll just do to finish is an idea. You could have a sky sphere, I've called it, like a skybox. All I've done is thought, wait a minute, if you just put a massive sphere around you and don't move that, and then you put like a nice starry background on, it'll look like you're in space. And then I think I've added like a pulsing light to this. This is the I've got to now change which JavaScript file we're running. So this is going to be many planets. There he is. Save that. Run. Save all. Save all. Save them all. Run that. And then we should be inside of space. There we go. Hopefully you can see that, and you see it's fading out and then fading in. I'm just using the sine function to change the lighting in there. Let me know in comments if you want me to tell you how to do that kind of thing, but there we go. And I've just got up and down, and all I've done there is change the player position on the y-axis. I haven't used any trigonometry, so I'm only using trigonometry for your Z and X movement to keep things nice and simple. Thank you very much for watching. Apology for the debugging unless you enjoyed it. It's quite nice to see some debugging. Have a lovely Christmas. If I don't see you before, goodbye. That didn't close the camera, did it? That's just that's the window. This is one. Goodbye. Happy New Year.